Hi all, welcome to GradStats 2024 Lab Series. In Lab 8, for our single categorical predictor, we're going to be conducting ANOVA-based regressions to focus on the differences between groups within a categorical variable. Now, we have a lot of weird work to do here with some releveling and coding, and we're running our analyses both in R and RStudio and in SPSS in the same video. Now we start with R because you're going to be learning a new trick in R. We're going to import a data set directly from a website. Like we're going to import archival data directly into R. And then from that, save a CSV that we can then use in SPSS later. Now, lots of different regressions we're running here with our single categorical predictor, getting a lot of hands-on experience with both 2-level and 4-level categorical variables and different types of coding schema we use to conduct these types of analyses. The materials you're going to need are the Lab8 script for R and the LabSheet for Lab8 single categorical predictor. So grab those things and we will get started. Your lab sheet gives a basic overview of what we're doing here with the ANOVA-based regression to look at categorical variables in a regression approach. And we have our goals for the lab. In preliminary, as usual, we're exploring the data set and checking out the variables of interest to give our readers some idea of the data set itself. Looking at the preliminary assumptions, such as normal distribution and homogeneity of variance, using visual inspection and tests. In the model testing, this is where we're going to use different coding schema that we've talked about to evaluate the single categorical predictor's impact on the outcome. So the treatment coding and the effect coding are the two coding schemas we're going to check out. We're going to evaluate and interpret a regression with a 2-level categorical predictor and also another one with a 4-level categorical predictor and what that looks like in the coding. And as usual, adding some skills to our toolbox, both in RStudio and also when we get to SPSS. For the data file, we're going to be using some real data from the National Center for Education Statistics. It's called High School and Beyond, and it's about high schoolers and their proficiency scores. Our variables of interest are write, which is a continuous measure of writing proficiency, and that is going to be our outcome for these. And then we have a couple of categorical variables we're checking out. School type, between public or private, so that's one categorical variable with 2 levels. And race, which is a 4-level categorical variable with the levels of Hispanic, Asian, African American, and Caucasian. And as we walk through this, there's 2 questions that we're asking and answering. Is there a significant difference in writing proficiency between school types? And then a different regression set is looking at significant differences in writing proficiency between students from different ethnic groups. And again, on each of these, we're going to do treatment coding and we're going to run it with effect coding and see how that changes our interpretation from the output to the write-up. So, to prep, we need to read in the data set and do a little bit of data cleaning to get it ready for our analyses. So we'll move over to our R script file, SingleCat script, and again it tells us about the goals of the lab. And here we have some information about the packages I'm expecting we're using during the lab and some background information about the data set itself. Again, our questions are there significant differences in students' writing proficiency due to school type or due to ethnicity groups? And those are two separate regressions we're running. We're just doing SingleCat at this time. So for prep, we want to read in our data. We're going to do something new here. We're going to read in data from a website. The website itself is the Stats IDRE UCLA website, where they run the same lab in their data set. So it'd be good to check it out as well. So when we run this script, it places the HSB2 with 200 observations and 11 variables in the environment. But notice we didn't get a chance to do any import tasks, like setting the factors for the categorical variable or telling R which one is the unique ID. So we're going to do that using script. Using the ablar, we're going to tell R to convert the ID variable to a character, and then write it back onto the data set itself. When we do this, something like this, it overwrites the original variable. So make sure that's what you want to do if you are running this one. So it stayed as 11 variables because I did an overwrite of ID, but now it's recognized as a character. So we're also going to deal with our categorical variables of interest and get them into place. So we need to turn the race variable into a factor. But to do this, we're going to make it a new variable so that we don't overwrite the old one, just in case. So here we're giving a new name to a new variable into the data set called race.f, and that is taking the race variable in the HSB data set and converting it to a factor and giving it the labels of Hispanic, Asian, African American, and Caucasian. Now, you do need to give the labels to RStudio in the order that they are. So you need to know that when you're doing this kind of thing, what order the variables are in. And you would look at the code book or look at the variable. You'd have to go back and look at the code book to know those. Because if you look at the other variable and it's just 1, 2, 3, 4, you're not going to know which one's which without the code book. And we're going to do that same thing to school type. So making a new variable, school type.f, that I'm converting to a factor, the old school type, and I'm giving it the labels public and private. So now notice that we've added 2 more variables into that data set. So now the data set has 13 variables in it. And I have a little side task for us to do. It's a new trick in R, and we're saving a data file from R to use in SPSS later. So what this says is write to CSV. The target is the data set, HSB2, and the new name of the CSV is going to be lab3 hsb.csv. When I run this, it's going to be in my environment, in my files, the same working directory that you already have set in RStudio. If you'd like more information on converting files out of RStudio into another format, check out the documentation here. So back to our RStudio lab. Now we're ready for preliminary. So in our preliminary work, we want to get that information just about the data set, the sample size, the variables of interest, and especially because we're going to be running a regression with the categorical variables, we want to tell our reader about the outcomes mean and standard deviation for each level within the categorical variable. And that helps us with setting up the table when we are making a descriptives table for the write-up. And checking out our preliminary assumptions, we will check the graphs and then also do tests. Okay, so first let's just get a summary and look at what's going on in this data set. When I run that, all of my information is down here in the console. I can see how many cases are by school type and how many cases by different ethnicity groups. I also have the the mean, median of the writing proficiency outcome that we're going to be looking at. And I wanted to show you a different way that you can also get some information and put it into the environment. Like if you already know you're going to want the writing mean and the writing standard deviation, you can go ahead and run it over there, and then they're handy instead of having to go back and forth to a table. But we do want some tabled values. So here we're going to use our tapply and call for the mean of each level of the categorical variable. So for that, my variable right, and then also my categorical variable, we'll do race.f and tell R that we want the mean. I forgot a 2 there. Remember that RStudio's HSB is not the same as HSB2 in the environment. So run that, and it brings it up in the console down at the bottom that my average writing score for Hispanic 46.458, for Asian 58.00, African American 48.20, and Caucasian 54.06. Alrighty, we want the same thing but now for school type. So I can copy, now that I have the script, I can just copy and change out the one that I need. School type factor. And again, it places the information in our console. So we're going to also want this information in our environment so we can get to it later and not have to scroll back and forth through the console to get the information. So here, what is this saying? Make a new environment object called descript race, assigned by the dataset HSB2, then group it by race, the race factor categorical variable, then summarize the mean and standard deviation if the variable is numeric, so if it's a continuous variable. And this will get the mean and standard deviation for all of the variables in the data set that are continuous, and ignore the missing values. So now when we look at this, we have by different ethnic group and all the mean and standard DVs for all of these. So I can see on right the average, and I also have the right standard deviation. Okay, and there aren't any missing values in this data set, but sometimes I just like having the script there so I don't have to figure out how to redo it later. So we want this same type of grouped summarized data grouped by school type. Well, now that we have the script, we can just take that and copy it, put it down here, and change out what I want to call it. I'll do that. For school, this will be school type factor, and then summarize. So a new item, and it's just got the public and private for those variables. Cool. Next on our preliminary assumptions checklist is to check out the normal distribution of the outcome and see if there's similar variation across the scores of the categorical variables or the levels within them. So we're going to work on those graphic skills that we've been doing with ggplot. Here's your basic formula for it. Plot, I want my data. Plus geom histogram. The aesthetics. What is my x value? Let's make the x value for outcome variable right. And then bin width 1. Okay. And that'll give us our first look at the distribution of the writing outcome, writing proficiency across both groups, across all groups, just writing, period. And for our Shapiro-Wilks, and we want HSB to, which variable are we after? That one. So the data and the variable. So we have the Shapiro-Wilk normality test coming in at a p-value very small. So it has violated normal distribution. But what if we want to see the distribution for each school type? We'll get our same ggplot, but now we're going to include some other pieces into it. We're going to add color equal to school type. There we go. So that gives us a different look at it. We still see somewhat of a negative skew going on, and the differences here is that we have a lot more cases in public than we do in private. But that adds a little more information. It helps your reader see what's going on with the data. So, and then we want to check out the Shapiro-Wilks normality testing for each of these levels, for public and private. And I think I'm still having issues with DLooker. We'll see. First, we'll just check out the normality of HSB2. For our right term, it is significant. It's a significant Shapiro-Wilks, but we also want to check out by categorical variable. There we go. So between public and private, our p-value for public was significant, but our p-value for private was not. So now let's check out the race categorical variable. We'll use that same inspection to look at what does this spread of scores look like. Here, let's look at a bar graph. So the dodge kind of shifts over each of the levels there, so we can see, again, you're seeing the count. Like there's a lot more Caucasian in the data set than African American, Asian, and Hispanic. And then here we'll go ahead and do that same normality test, checking out the Shapiro-Wilks across levels of race variable. Again, we have a non-significant Shapiro-Wilks test for Hispanic, Asian, and African American, but it is significant for Caucasian. So it seems like the spread, the violation of normality is pretty much all within the Caucasian variable or level. Again, if DLooker is being problematic, you would use filter to choose only the categorical variables of interest and save them in the environment. And run Shapiro tests on each one of them as well. As we go through seeing the tests there in the console as I run them, you can look and see which ones are coming up significant. And that you would let your reader know when you are reporting about your check of the assumptions. So next we're going to check the variation of writing proficiency scores by looking at some box plots. Here we want our categorical variable. So we'll do race, and y will be the outcome variable. So x and y. There we go. So looking across our race groups, our ethnic groups here, you're looking at the spread. Is the fatness of this block significantly different? That's what Levine's test will show us as well, but this is our visual look at what's going on here. And then let's do the same thing for the school type. And we'll change this. There you go. Now here you're seeing, like, see how shallow this spread of scores is compared to this one? That's what we're talking about when we say that the variation looks different. And we use Levine's test for testing that out. There's school type. And Levine's is significant for, there's differences in variation between the school types. And we'll do the same thing for race variable. Running that. This is not significant. And remember, this is the biggest, looks like the most spread. This one looks like the least spread, and apparently the differences there are not significant. The difference in variation on right. Okay. So just another extra visual here for you guys. Depending on what your research question is and the type of audience, you want to play around with the aesthetics that we learned in ggplot in Lab 0. So here, saying that I want a box plot of race by right with a fill and coordinate flip. Let's look at that. So that's a kind of a different take on looking at the differences between public and private on the writing variable and looking at difference in race. So it gives you an idea as to what might be coming up as we go into the analyses on, are there significant differences there? So let's take a look at the lab sheet itself. We've done all of this preliminary pulling information. What can we say about this first look of the data and the variables? Well, we can tell the reader where it came from and what the variables of interest are. We can tell the reader about the visual inspection of the histograms and the visual inspection of the box plots, and letting the reader know what tests were either supported or violated or confirmed our visual inspection. You also want to let your reader know if you're including a figure, you tell them in the text. And it helps to just move people along in your write-up to what's coming next, because next would be model testing. You can give your reader a heads up by a transition sentence telling them that you're going into model testing. So in model testing, we're going to start with the first question. Is there a significant difference in writing proficiency between school types? And we're going to be working with treatment or dummy coding first. The first thing we need to do is assigning treatment contrasts to the school type variable. So this says using treatment type of coding schema on the HSB2 dataset and the variable school type factor, and it has 2 levels. So it's this whole line here, what it says. Running that. So how is our assigning the 0 and the 1 that we use in treatment coding when we're doing dummy coding? One level is coded 0 and the other one's coded 1. Well, we can ask R what it's doing on the background there. This contrast, after we've already applied the contrast coding, we can run this and it tells us down here in the console that public is coded as 0 and private is coded as 1. So that's good. We know that the referent is public. Now we're ready to conduct that regression. This is just the name I gave it. It means write by school. And then I put .tr just to remind myself when it gets over here in the environment that it's the treatment coded one. And then this is assigned by the linear model, open parenthesis, the DV, the dependent variable, predicted by the categorical predictor in this data set, HSB2. So that adds that into my environment with list of 13. But then I'll call for a summary of it. And this is where I have all of the information for that f-stats line. We have the f value, we have the degrees of freedom, we have the p-value. We also have the effect size, the multiple R square, right there. So that is the information we need to report the overall model. The coefficients themselves, the intercept, that b sub 0, is 52.25. And the regression coefficient of the target, the one coded 1, is 3.28. So looking at these results, is the model significant? No, it's greater than 0.05. What does the intercept represent? That's this number right here. It's referring to the mean of your referent. Who's our referent? The one coded 0. So public schools are the referent. The mean of the referent is 52.25. the mean of writing proficiency. What does the slope represent? The slope is this regression coefficient for school type F2. It is the difference between public school and private school. So if this is the mean for public school, private school is 3.2812 greater, positive number. So how do we use all this to create our prediction equation? We take that 5225 and the 3.28. So writing predicted is the average of public school plus plus the increase or the change that would be for private school, because they're coded as type 1. So to get the average for private school, we just add those numbers together, 5225 and 3.28. And the difference in writing proficiency scores was not significant because the p-value was greater than 0.05 for the regression coefficient as well. See, looking at this, right now it's the same p-value for that coefficient as it is for the model. That's not always the case. The only reason it's the same right now is because we only have one predictor in there. Okay, that's treatment coding when we are comparing to the referent. The second type of coding we use is contrast effect coding. So we're going to look at that for the same question about, is there a difference due to school type? But now we're comparing to the grand mean, and the grand mean is the average across those groups. So if we looked at average writing proficiency across public and private means, the grand mean would be that value, and we're going to get it running this regression. So first we need to assign the effect contrast type to the school type variable. So we're telling RStudio use contrast, apply contrast to this variable, and use the type called contrast.sum, and there's 2 levels. So running that. Now we're ready to run another regression, but give it a new name in the environment so you can keep track of leveling. So this one I called write by school CT1, so contrast type 1, assigned by the linear model of the outcome right predicted by the categorical predictor school type in this data set. And I can call a summary for that. So here's our grand mean, the mean of public and private. And here's the difference between who's coded as 1 and the grand mean. So who is coded as 1? We can do what's called contrast of that variable. And find out where R has it right now. Right now public is coded as 1 and private is coded as -1. So the level that's coded as 1, public, this refers to that variable or that level. The variable is still school type, but the 2 levels in it, we're focused on the level called public. Public is -1.641 different than the grand mean, than the average between those groups. Notice that our f-stat is the same, our R² is the same. The only thing that's different is right here how we're interpreting the coefficients, the intercept and the regression coefficient. That's the big difference on interpretation here. We have the same p-value. Okay. The intercept represents the grand mean. The slope represents the difference between the grand mean and the group coded 1. So what does our prediction equation look like now? So when we use effect coding, now we have this equation, the grand mean and the regression coefficient for public school. So now we're going to do what's called re-leveling to get the comparison between private school and grand mean. So first I'm going to look at what the current levels are. Right now they're in the order of public then private. And then we're going to use a re-level function in the 4cats package. And it's already part of tidyverse, so you should already have it loaded. And we're going to re-level so that private is now in the first position. So first, I'll run this factor re-level of the HSB dataset school type point.f variable and moving the group private to the front as levels. So it moved private up to the front there. But I need to keep this. I want to write it back onto that variable. So right now I see it in the console, but I need it to take effect in the data set itself. So I'm going to, because like before I run this, if I run table, it still has public first. But I need to use that that call, that request to re-level and write it back onto the variable. So that's what that's doing there. So once I run that, I'm going to run this table again and see now private is first. So you have to write it back onto the variable to get it to take. Okay, now we're ready to run to reapply that contrast coding to our re-leveled school type. And once we have that all set, we can do the next regression. So I named it the same thing, but then contrast to, which is assigned by the linear model of right predicted by school type in that data set. And I can call the summary. So how has this summary changed? And how does it change the prediction equation? Notice that the f-stat is still the same. The r squared is still the same. So the overall model does not change. The only thing that changed here is the coefficients. 53.891 is still our grand mean. That didn't change. But now school type is no longer negative. It's a positive number. And that's because now 1 refers to private. Like if I do the contrast, to find out where they're at, now private is coded as 1. And again, when we're doing effect coding, the deviation type, the regression coefficient here refers to whichever level is coded as 1. So the difference between private and the grand mean is 1.641, a positive. So that changes our regression equation that way. Really the only difference was the sign of that regression coefficient. And that's only because we have 2 levels. If we only have 2 levels, you really only have to run the contrast code once. and same with treatment coding. If you're only comparing two things like male and female or public-private, then you really only have to run it once because you have the information for the other one already. Okay, so going back to our lab sheet, we're going to look at our next question. Is there a significant difference in writing proficiency between students from different ethnic groups? So using treatment and dummy coding, we're going to start that way, and that's where we're comparing to a referent. Again, first thing we want to do is tell R to assign the treatment coding to the race.f variable. We're saying use the apply contrast, use the treatment coding schema to this data set, this variable, and there are 4 levels in it. And then we're ready to set up the regression. This one I put writing by race.tr1 so that I know that it's the treatment coding, and you can give it any name. You can give it a long name, whatever makes sense. I'm going to assign, this is assigned by the linear model of right predicted by race in the HSP2 dataset. So running that and getting a summary. So now we have more information here, right? We have the F statistic, we got the p-value, we got the model, the effect size of the model. So all of that is in your overall model. Now looking at the regression coefficients, the intercept is the mean of the referent. Well, who are the referent? Who is the referent? Let's see what order it's in. It's in the order of Hispanic, Asian, African American, and then Caucasian. So that means my referent is going to be Hispanic here. So the average writing proficiency score for Hispanic ethnicity group is 46.46. Then each of these is going to be the comparison between the group it refers to and the referent group. So you can see that we need to keep track of who is who. And this is where it helps to have like a table to work with, or someplace where you keep notes on, for each regression run, which level was in referent location. So now that we have all the regression coefficients for each of our groups here, we can write our regression equation. So back to our lab sheet for that. When we had Hispanic as referent, we had the y-intercept, we had the regression coefficient for Asian, the regression coefficient for African American, and the regression coefficient for Caucasian. Those are all in the output right here. And you can let your reader know what's going on with that. Average writing proficiency scores were compared to the referent group Hispanic. Significant differences were found between Hispanic and an Asian. How do I know that? Because of the p-values right there. There is a significant difference between Asian and Hispanic. There is not a significant difference between African American and Hispanic. And there is a significant difference between Caucasian and Hispanic. Everything's being compared to whichever group is in the referent spot, coded 0. Notice that we don't have some other comparisons going on. We don't have the comparison between Asian and African American. between Asian and Caucasian, nor between African American and Caucasian. All we have right now are the comparisons with Hispanic, because Hispanic was in the referent role. And it will take 2 relevels to get to these comparisons. So if we have 4 levels, it requires 3 regressions. We already did 1, so we got 2 more to go. So when we want to relevel in RStudio, in the treatment condition, we're going to use the R-base relevel function. So again, let's look at where they are. They are currently in the order of Hispanic, Asian, African American, Caucasian. We're going to use the relevel function to make Asian the new referent. So for this variable, race.f, I'm going to relevel it with the new referent being Asian. So when we're using treatment coding, this is how you relevel. And now we're going to look at that same table to see how it goes. Now Asian has moved to the first position and Hispanic has moved down the line, right? We're going to reapply the treatment coding after that releveling. And then rerun a new regression with a new name. So this one I called Writing by Race Treatment 2, the linear model of right predicted by race, and get a summary for it. So now we have the comparisons for Asian. What new information is here? Because we already had the comparison between Asian and Hispanic. What we don't have is the between Asian and African American and between Asian and Caucasian. So in our regression coefficients down here, we see the average for Asian, we see the comparison between Hispanic and Asian, which we already had, but now we also have the comparisons between African American and Asian, and between Caucasian and Asian. So we can go right in these terms into our next regression equation. When we have Asian as referent, now we have these. You still include the Hispanic term in the equation, even though we already had it up here. But now we have between African American and Asian, and between Caucasian and Asian. So one more relevel, because we still need to get the comparison between African American and Caucasian. So we're going to relevel to move African American up to the front. And with that there, we're going to reapply the treatment coding and then make a new regression, the one with, I'm calling TR3, so that I keep them attractive. So now what do we have in summary? We have the mean, the average writing proficiency for African American. We have its comparison to who? We will find out. We can get the table and see what order they're in. So here's Asian as the second level. So that's the comparison between African American and Asian. Here's our comparison between Hispanic and African American, which we already had from a prior. And here's the one we really needed, Caucasian, the comparison between Caucasian and African American, because we had the other values from the prior regression runs. Now, keeping track of which level is what for each of your regression runs is a good idea. One thing I do to keep track of it is to use an Excel sheet where I can name which regression and where things were for each of those regressions, who was referent and who was in like second, third, fourth position for each of them. And then the next thing we'll do is look at this same question, but now with effect coding. So instead of saying that we're comparing to a particular group, the referent, we're going to compare to the grand mean. So moving to that, coding the race variable when we are doing effect coding, comparing to the grand mean. We've done several relevels in the race variable at this point, so let's take a look and see where things are at. Right now, African American is at the beginning, Asian is second, Hispanic is third, Caucasian is last. So it's good to keep track of what is where. So now we're going to assign a different type of effect coding. Just like we did with the school type, we're going to assign a contrast, effect contrast to the race variable. So applying the contrast to the race variable using the contrast sum or effect called sum, and it's got 4 levels. Then we're going to run a regression. I called this one right by race contrast 1, assigned by the linear model of right predicted by race in that data set. And if we take a look at our contrast again, you'll see that now it's no longer treatment coded, it's effect coded. And when we do effect coding, you pretty much have a base group that's not going to be in the regression at all. It's coded as -1, and then you have your target that's coded as 1. Everything else is coded as 0. So we're ready to run this regression. I've named it right by race contrast 1, and let's get a summary. Here we see that the intercept 51.678 and 3 regression coefficients after that. So first, is the model significant? Is the overall model significant? According to the f-stat, yes. P-value is very small, less than p0.05. We have our F statistic estimate and the degrees of freedom. And we have the multiple R squared effect size there. When we're looking at the intercept represents the grand mean because we're doing effect coding. Then race factor 1 is going to be, when we pulled that, the one coded as number 1 there, African American. So I wrote it down in my sheet that when I did right by race, contrast 1, African American was at the first point, F1. So that's what I mean by keeping track of it, so that when you look back later, you know for this regression who was where. So the difference between African American and the grand mean is significant. And the difference between number 2 is Asian, number 3 is Hispanic. So number 2 here, the difference between Asian and grand mean was significant, and the difference between Hispanic and grand mean was significant. So now what does this prediction equation look like? So now we're going to have this first one, our values from the regression equation for each of the groups within the race categorical variable. So notice that that last factor, Caucasian, does not have an estimate. It's because that one falls off the end and we have to re-level to get it into the equation. But because we're comparing all of them to the grand mean, we only need to re-level once to get that last group, Caucasian, compared to the grand mean. So going back to the 4 cats, when we're using effect coding, use 4 cats to re-level, which is this function right here. So I'm going to re-level and put Caucasian up into the front. Once I've re-leveled, I have to reapply the contrast coding. And now I can look and see. I can double check contrasts to see where R put them. Caucasian's at the first, and then it put African American next and Asian next as far as for the rows 2 and 3. And then my new base is Hispanic that will not be in the equation. So there's where it's at. We still need to run the regression and check the summary. So same, the F line didn't change, guys. Every time the overall model stayed the same. The only thing that changes is those there in our regression coefficients. So now I have the comparison between Caucasian and grand mean, and I can write that equation and kind of give the lowdown on what's going on. Caucasian was also significantly different right there with the p-value less than 0.05, significantly different than grand mean. Okay, so what's left to do? We've run all the regressions. We've done the regressions according to school type, both ways, treatment and effect coding, and we've looked at differences due to ethnicity groups, and we've run that using treatment coding to compare to a referent group, and we've run it using effect coding to compare to the grand mean. So we have all of that done. What's left for the write-up here? Well, I'm going to have you guys go ahead and start working with confidence intervals for the effect size for R squared. And we do that with a package called mbes. We need to get some information out of the regression to put into this function called CI R squared, confidence interval for R squared. We have to look at the R squared value. So this one for school type regression, I can go back to one of my school ones, because remember the overall model didn't change. It's got the same R squared and sample size and all of that for all of those. What I want is summary for right by school. It can be any of them. And then I'll have my R squared, which I put right there. I only have one predictor. The predictor is the categorical variable of school type. And my N was 200 observations, right? So you fill in the information, and then you have your confidence intervals for R squared. So it's running, so this part, probability number, that's the last 2.5%. Here's the upper 2.5 because it's the 5% confidence interval there, the 95%. So you have the 2.5 and 2.5. It's a two-tailed test, right? So, but here, my lower limit is 0. My upper limit is 0.0680. So that's my confidence interval for the R squared for the school type. I'm going to get the same type of information out of one of those race regressions. Again, it doesn't matter which one because the overall model didn't change. It's only the coefficients that change. and we're trying to get the confidence interval for the effect size of the overall model. Okay, that's how you get that. Let's see. And we want to finish working with the descriptives table. So remember when we were getting all that information up at the beginning, like descript race, descript school, we can also use some of our deployer tools to organize and get everything up to the front. Like if I want, instead of right being all the way at the end, remember when we look at this one and we got to scroll over to get to right? Well, we can go ahead and move it up to like the beginning. And then because we put things in so many different orders, I'm going to go ahead and re-level, not so that I can run a contrast, but so that I have them in alphabetical order. And then I'm going to call for a new descript table, and I'm going to have the race and the school type in there so that I have the mean and standard deviation for writing on both of those. Let's take a look at that. So I have the race variable and the school type variable and the mean for writing. So in private school, African Americans in private school had a writing proficiency mean of 51.5. African Americans in public school had a writing mean of 48.83. And then I do have to scroll down to get to the standard deviation there. So we have all of the information to start building a descriptives table. Let's take a look at what that might look like. So African American in public school, right there, and African American in private school. So you would set up your table with all your information, and then you would still do some editing to bring it into Word, like, merging and centering and lining up the decimals, things like that we've looked at before. And once you get it all prettied up, it would look something like that. Some other things that you can get are the count. So I put a little item there that it quickly gives you the count, but you could also just pull the summary, right? Summary of HSB 2. Well, that'll give us the overall summary, like how many African American total, but it doesn't tell us how many are in private and how many in public. But this one breaks it down to those groups. 2 African American cases in private, 18 in public. Alrighty. And back at our lab sheet, I kind of scrolled over it, but there is an example results write-up where you pull it all together. You tell your reader about the basics of the data set, your preliminary checkover of it, and then your regressions. Now I separated out the regressions for treatment versus effect coding because you would only have one question that you are reporting to your reader. You're not doing both of them. You're either running treatment coding because your question has to do with comparing to a referent group, or you're running effect coding because your question has to do with comparing groups to the grand mean. Normally you would not have both write-ups to the one regression. Have the prediction equations in there, and then the same kind of thing for the race regressions we were running. Again, you would not have both of these paragraphs. It would depend on what your question is, and then the equations that go with them. Alrighty, the table, I have some figures there, that you can check out. And this would be a good place for a break. Take a little pause, go shake it off, and next we will start the lab for SPSS. Those same approaches we just completed in RStudio, we're going to conduct in SPSS to answer the questions about writing proficiency scores being different according to school type or being different according to ethnic group. So now for our prep, we're going to read in that CSV file you saved from RStudio, the one we called Lab8 CSV. So start the SPSS and go to File, Import Data, CSV Data, and navigate to where you saved the Lab8 CSV file. So File, Import Data, CSV Data. Once you're there, navigate to where you have your working directory for RStudio, because that's where it would have saved the CSV file. It's going to take a second to kind of find itself there. Then you hit OK, and it loads into SPSS. We're going to go ahead and save this as, I think I said, Lab8 SingleCat. And it's going to save as a SAV file. So let's take a look at what we have here. We have that SPSS thinks that ID is a scale variable. Well, that is not true. We're going to change it to nominal. And notice that none of the information was brought in as far as what these different variables are. But it did bring in our race factor and our school type factor that we made in RStudio. So we need to correct some items that SPSS didn't pick up on, including changing that ID variable to nominal, and also adding values for school type and for ethnicity. And we're making these changes to the one that's got the numbers in it. What I mean by that, looking at our race variable here, the one we made with labels like Caucasian, African American, like there, we need to use that to help us see that we are on the right track with this variable, that Caucasian is 4, or that public is 1. See what I mean? But the ones we're going to put the labels on are this race variable and this school type variable, not here. We're going to leave those as nominal variables. We're going to come over to race and school type where it's got the numbers and put the labels in the variable view. So for school type, you come over, we can go ahead and put a label on there. And the values, 1 was public, add, and 2 was private. We'll add that one. And we need to do the same sort of thing for the race variable right here. Ethnicity. And in values, you're going to add the values for the 4 areas. Number 1 was Asian, adding. Number 2 was, nope, I'm wrong. Number 1 was Hispanic. Change. Number 2 was Asian. 3 was African American, and 4 was Caucasian. So now we have these guys labeled, and then our outcome was writing proficiency. Let's see. Okay, now we're ready to gather some details about the data set, like frequencies for the categorical variables, descriptives for the continuous variable, those basic data set information that we need. So I'm going to go to Analyze, Descriptive Statistics and Frequencies for the categorical variables. And they are race and school type that I'm interested in. And I'm pretty much ignoring the ones that we made in RStudio. So I'm going to paste to get my syntax started up. And it already has my frequencies there. This is where you can leave yourself notes. Always end your comment with a period. It starts with an asterisk and ends with a period so that it will start reading the coding again after that. So I can run that. Command R will run as a keystroke, or you can just grab the syntax and use the green arrow. So I have race and school type. And I also want to get analyze descriptive statistics descriptives for the continuous outcome variable of right. And there I have the average for right is 52.77 and the standard deviation for right. Okay, next I want to get descriptives of the outcome by group level. So between public and private schools, or between the different ethnic groups. So here I'm going to go to Analyze, Compare Means and Means, place right in the dependent list, place race and school type in the layer, and then paste that to syntax. So I want compare means, analyze, compare means, and then means. We're going to, the dependent variable is right, and the variables of interest going on are race and school type. And I just use a control or command key to select them like that. You want your race and your school type over in the other section here. And then we will paste our syntax and run from there. So now we have the average writing proficiency score across all of the different ethnic groups, and we have the average writing proficiency scores for the different school types and the standard deviations as well, which is what we'll need for the table in the write-up. And you got your count for each of them. Alrighty. We want to do a visual inspection and tests of the preliminary assumptions. We're going to use Explorer to request the histograms and normality plots by categorical level. So I'm going to analyze descriptive statistics and Explorer, putting right in the dependent list and race and school type in the factor list. And then I need to make sure in plots I select histogram and the normality plots. So let's go do those. Going to Analyze, Descriptives, Explore. I'm putting right in the dependent list, and then race and school type in the factor list. In plots, I'm requesting the histogram. I don't need the stem and leaf. I'm requesting the normality plots with tests because that's where I get the Shapiro-Wilks. Continuing and pasting. Okay, and again we have like the mean for Hispanic, Asian, African American, Caucasian on the right outcome variable. We have the standard deviation. We have lots of information in here. But what we're after first is this test of normality. We have the significance levels of Shapiro-Wilks, and similar to in R, the only one that is violating the normality is Caucasian. And we have the histograms pulled for it as well for each of those groups. Then same thing with school type. Scroll down in your output and you'll get to the school type and the test of normality for school type. It looks like public had a non-normal distribution, but private was fine with that. And we got our histograms according to school type. So that's our visual inspection of the histograms and the Shapiro-Wilks test all together. Now notice in the output right now with the Explore output, we already have some box plots there. So we can visually inspect the box plots regarding the homogeneity of variance there. Let's take a look at them. Down at the bottom, we have public and private box plot. And at the bottom of the race, we have those. So again, looking at the spread of scores, comparing between them. Now to actually get the Levine's test, we're going to need to run a one-way ANOVA for each of these. So using the one-way ANOVA, we're going to request Levine's test for homogeneity. We'll go to Analyze, Compare Means, One Way, and place right in the dependent list and race in the factor. In options, we need to select that homogeneity of variance test, and then we'll paste that into syntax for it. So in SPSS, I'm going to Analyze and then Compare Means and One-Way ANOVA. At this point, we're going to put right in the dependent list, and then the factor is going to be race. We're going to go into options and make sure we are asking for the homogeneity of variance test. Continue there, and then at this place put paste. And let's check out the syntax. Right by race, homogeneity test, skipping missing values, and the confidence interval of 95%. So I'm going to run that. And here we're seeing the very top line, looking at right across the different groups of race, right? And we see that none of the Levines, the Levine is not significant. So there is no violation of homogeneity of variance across racial groups. Here, we're going to go back to our syntax. Instead of all those clicks, the only thing we really need here is to change the factor. So we want school type. and then rerun your one-way ANOVA for the test of homogeneity by school type. And here it is violated. It's less than 0.05. We're pretty much just looking at the top one. The median and the median with adjusted degrees of freedom are more, they're the alternative you use when the distribution is not normal. And the distribution is not normal, so we could use the other one, but no matter what, all of them are significant. So there is a significant violation of homogeneity of variance when we're talking about school types, so between public and private. So we have our tests, we have our Levines, we have our box plots for visual inspection. Let's see what's next here. We're ready for model testing. And again, once you have your preliminary work done, it's a good time to start your write-up. Go ahead and start explaining to your reader what's going on with that data set. But now we're going into model testing, and the first type of coding we're going to use is the treatment or dummy coding. We have to set up dummy coding for the categorical variable of school type because with 2 levels. Remember, school type came in coded as 1 and 2, and for dummy coding we need 0 and 1. So we're going to transform and recode to different variables. Using school type in the input variable box, we're going to change public to 0 and private to 1. So go do that. In SPSS, I'm going to go to transform and recode into different variables. For here, we're going to put school type into our numeric variable, like working box here. The outcome name, let's call it school dumb. And we're going to label this as the comparison between public and private. And hit change. In old and new values, we want the old value of 1, that's public, to be now the referent, 0. We want the old value of 2, that's private, to be 1, the target. So here we can hit continue, and then we're going to paste. Running that code, I do have, see when I just click on that at the end, it doesn't do one of the bar things on the side saying that it's going to run the whole thing. So when I see that, I go ahead and select all of the code so that I make sure the whole thing runs. And you'll know that it ran if you have a new baby variable there called school dumb. So now that we have that dummy variable, we're able to set up the regression. But this is a good time to start tracking what you're coding. Like, I don't really need it as much for a variable that's only got 2 levels, but it's good to get in the habit of knowing for which dummy variable, which group is called referent and which group is your target. As we have more levels in the categorical, it'll get a little more involved. But we are ready to request the regression for right predicted by school type. We're going to go to Analyze Regression Linear, put right in the dependent and school dumb in the independent, and then put that into syntax to run. So back over to SPSS, Analyze Regression Linear. Here we want write into the dependent, and we want schooldom in independent. And then paste, and let's check out the syntax. So here we have the regression. We can see that schooldom is the independent variable, the dependent variable is write, and we can run this. And here is the same information we were getting in R in the console. We have it here in these tables in our output. We have the overall model. There's our F-stat. Here's our degrees of freedom. Here's our significance level. We have our R squared effect size. And we have the coefficients. Again, the intercept, the constant there, is the average writing proficiency score for public school, whoever is referent. Schooldom is going, the dummy variable is going to be the difference between the referent and the target, between public school and private school. And that's the information we needed to create that regression equation. Notice that we don't have the confidence interval for R squared. We're going to go to this website called Daniel Soper Calculators. Okay, so we need to give this calculator some information. How many predictors? 1, just school type. What was the observed R squared? And what is the sample size? So going back to here, our sample size was 200. Scroll back up to our information. 200 is the sample size, right? But then we need to know the R squared coming out of that last regression model, and it's 0.16. So observed R squared, 0.016, and sample size 200. And there's my 95% confidence interval for that regression. All right, so our equations. The mean for the referent, public school mean was 52.25. And then the regression coefficient for the target, whoever was coded as 1. Private school was coded as 1. And the difference between public and private school is 3.281. Is that difference significant? No. And again, once we have one, when we only have 2 levels in the categorical variable, the difference between public school and private school is not significant. Well, that means that the difference between private school and public school is also not significant. It's the same regression, and the only thing that changes when you change the treatment person, like the referent from the target, is that the sign would change. So we don't need to run a second regression when there's only 2 levels in the categorical variable. We have to run more regressions and more dummy variables when we have more than 2 levels. But let's take a look at effect coding. With effect coding, again, we are comparing to the grand mean, the mean of means between those groups for writing. So here we're going to set up a different type of coding. We're going to set up effect coding where public is going to be set as -1 and private will be set to +1. So going there, and we're going to call it school dev 1. There you go. Transform, recode to different variables. And here I'm going to go ahead and reset this so that I don't have any numbers in there that confuse me or get me off track. So I'm going to reset the whole thing. and then put school type back in. And this time the name I'm giving it is School Dev 1. And I'm going to call it Compare Between Private and GM. So whoever is the comparison is going to be coded as 1. Anyone else is going to be either a -1 or a 0, depending on how many levels you have. We only have 2 levels, so public is going to be a -1 because your effect codes have to sum up to 0 in the end once you have all of them in there. We only have 2, so one has to be 1, so that means the other one has to be -1. So I'll hit change here, and then in old and new values, the old value for public school was 1, and what I'm going to give it is a -1. Private, that's going to be my target, is going to be, or used to be 2, and it's going to be changed to a +1. So once you have that, you hit continue and paste. Going over to our syntax and grabbing that to run. So I have the new variable called School Dev 1, and it's the comparison of private with grand mean. Now we're ready to run the regression. For our regression, we're going to go back to Analyze, Regression, Linear, and then I can go ahead and reset this to wipe everything out, or I can just take school dumb out and put school dev in. I'm going to paste here and go check out the syntax. So all that changed was instead of school dumb, I have school dev. Running that. Now we have, again, the overall model didn't change. We have the same F stat, the same degrees of freedom, the same significance level for the overall model, and the same R squared. So all of that information did not change according to what coding type I'm using. What did change is the coefficients, because now I'm comparing to the grand mean. The mean between public and private was 53.89. The difference between private and grand mean is 1.64. So that's all I need for writing up, and I know that it's not a significant difference. So for private school, writing proficiency was predicted to be 1.64 more than average writing proficiency score between school types. The overall model indicated no significant difference between private school and average writing proficiency. And as we saw in RStudio, when there's only 2 levels in the categorical variable, the other level is just the same equation, but with a different sign on the B1, the regression coefficient. So we can already write the next regression line. It's pretty much the same line. Let's see about working with race or with categorical variables that have more than 2 groups. And now that we have some syntax built, we can start moving a little faster because we don't have to click through all of the little drop-down menus. And here's our tracker to keep track of the coding. It's kind of more important in SPSS because we have to make the dummy variables. SPSS doesn't make them for us. Or like R, we would just apply the treatment coding or the contrast coding. in SPSS, we have to create these dummy variables. So we shall take a look at the syntax. What we want, let's grab one of these recodes right here. So think about it as we want to have, for the race variable, Hispanic is coded as 1, Asian 2, African American 3, and Caucasian 4. So we're going to say recode race. We have 1, 2, 3, and 4. And we're going to code this first one into dum1. Right? For dum1, we want Hispanic to be the referent. So I can already say 1 is going to become a 0. So that one's good. We want Asian to become the target. So Asian number 2 is now going to become 1. Everyone else is just going to get a 0. So 3 will become 0 and 4 will become 0. And then here we want, this is going to be dum1. And it's the comparison between your referent and your target. So between Hispanic and Asian. See that? See how it's red here and it's red over here? It's trying to let me know something's not quite right yet. So see that I forgot an opening parenthesis there, and now everything kind of lined up and stopped being so red. So recode race, 1 is going to be my referent, that's Hispanic. 2 is going to be my target for dum1. And then the other 2 are just going to be zeros. So I need 2 more of these. I'm going to copy and paste and paste. So here I want dum2, and this is going to be dum2 here. And this one's going to be the comparison. So I'm looking at this guy. I want the comparison between Hispanic and African American. So my numbers are going to be 0, 0, 1, 0 across. So I want for dum2, 0, 0, 1 for African American, and 0 for Caucasian. So dum2 is going to be the comparison between Hispanic and African American. Okay, one more to go. Dum3, need to change it at both places here, is going to be my comparison between the referent Hispanic and the target Caucasian. And my numbers need to be, my referent is 0, my target is 1, everyone else is 0. There we go. So now I have my dummy codes all ready to roll, and I can select them all and run. And then I see that it's made some new variables. And if I look in the data set, they're right there. So now I'm ready to run the regression. I'm going to go to Analyze, Regression, Linear. I'll go ahead and clear out school dev, but add dum1, 2, and 3. And then this is ready to paste. So now I have the regression looking at the dependent variable right and DUM 1, 2, and 3 in there, which are the race dummy variables for the race categorical. So we will run this, and now look at our full model summary here. We have our fstat line, we have our degrees of freedom, we have our significance level. It says it's a significant model, and the R-square is 107. But now let's look at these coefficients. With treatment coding, we're comparing each thing to the referent. So our referent on this one, across all three, the referent is Hispanic. So all of these are getting compared to Hispanic. For DUM 1, the comparison is between Asian and Hispanic. So the difference in writing proficiency scores on average between Asian and Hispanic is 11.542. For DUM 2, it's between African American and Hispanic, right there, 1.74. And then for DUM 3, it's between Caucasian and Hispanic, 7.597. And that's the information we need to write the regression equation. So when Hispanic was referent, we just go from our information there into our regression equation and tell our reader about it. Notice this one, DUM 2. And DUM 2 was the comparison between African American and Hispanic. That is not significant. So there's a significant difference between Asians and Hispanics, between Caucasian and Hispanics, but not a significant difference between African American and Hispanic. So now we're going to pretty much like re-level, but instead of re-leveling, we have to recode. We have to recode 3 more dummy variables to run the next regression, and then another 3 to run the last regression. So that's why it takes a little bit more in SPSS to run multiple regressions like this to make those comparisons. So it helps to start working with your syntax. If I want to have, for regression 2, if I want to have Asian as my referent, then really what I'm saying is to do another set of recode and now I'm going to have DUM 4, DUM 5, and DUM 6. Now, what are my comparisons here? For DUM 4, for all of them, I want the referent to be Asian. But for DUM 4, the target is Hispanic. So my numbers across will be 1, 0, 0, 0, because here we don't have anything there. Anyone else is just going to be a 0. So our target is going to be Hispanic. Our referent is going to be Asian, and everyone else is 0s. And this is to compare between Asian and Hispanic. And we already had that, but we have to still do all of the regressions to get all of the comparisons. And that's why it's good if you're doing a planned comparison. Like, let's say the only thing I was really interested in was the comparison between Hispanic and African American. Well, then I already have that information, right? But we're running through so that we can look at dummy coding multiple times and getting all of the comparisons. So I have here for DUM4, my target is Hispanic, my referent, number 2, is Asian, and then everyone else is 0. For DUM5, my target is African American. So that looks good. 0, there's my referent, there's my target, there's 0. And that's between Asian and African American. Good. For DUM6, it's between Asian and Caucasian. Right there. So everyone else should be 0s. Asian, Caucasian, yeah. So I have those 3 ready to roll. And what we need next is the regression. So it's the same regression. I'm going to copy and just move down. But now, and it's good to leave yourself notes, with Asian as referent. Put a period at the end, and now this is going to be DUM4, 5, and 6. And that's ready to run. If you select your notes as you're running, the notes will be in your output as well, if that's helpful, you know, to see your notes with the actual output. Right there. And you can edit in your output. Like if I wanted to really make that stand out, I could either give it a color so that I can look at the output and see both my syntax and my comments if I select them when I run from syntax. But here's our model. Again, the F line stayed the same, and our coefficients are comparing to Asian. So my comparison from Asian to Hispanic, from Asian to African American on DUM5, and from Asian to Caucasian on DUM6. And that gives us this regression equation using the information from here for each of those groups with Asian as referent. Okay, one more, because what we don't have yet is between African American and Caucasian. Like, notice how the paragraphs start getting smaller. I don't have to write up everything that we already know. We're running the other regressions so that we can get to the information and the comparisons we don't have yet. So I have one more. It does mean I got to make another 3 dummy codes to run that last regression. So we will, regression number 3, I'm making 3 dummy codes, and the only one I really need out of this is that last comparison, but I need all 3 dummy codes to be able to do that. So making dummy 7, 8, and 9. I'm gonna copy. I can leave myself a note. Paste and work with these guys. 7, 8, 9. Gotta make sure I change these, or it'll change the label on my ones that I've already made. So that could happen if you forget to change right there as well. It'll give a label to the wrong one. So here my referent is African American. So that's my referent on all 3 of these dummies. And Hispanic is my first target, so it should be coded as 1. So it's going to be 1 0 0 0 1 0 0 0 for DUM7. For DUM8, I'm going to have 0 1 0 0. dum8, 0, 1, 0, 0. And this is between African American and Asian. There we go. And then the last one, dum9, 0, 0, 0, 1, 0, 0, 0, 1 to dum9 between African American and Caucasian. There we go. So there's the three set of three dummy codes I need for the last regression. And again, I can just copy the regression syntax and edit it accordingly. I want dummies 7, 8, and 9. Alrighty. So now we have our output. Again, our overall model did not change, but now we have African American as the referent. We're comparing for dum7, we're comparing Hispanic. For dum8, we're comparing Asian, but those we already had. Really, the number we didn't have yet was the comparison between Caucasian and African American, which is dum9, 5.855. So now we're ready to write that last regression with African American as referent. Still all of the numbers go in, but this is the number we were missing for Caucasian, the comparison between Caucasian and African American. Okay, so next, going to go through our race comparisons, but now we're comparing using effect coding, and we're comparing to the grand mean. So first, we want to determine which comparisons we're interested in and how this is going to play out in the coding schema itself. So here's a tracking chart to help track where I'm going with the effect coding. Notice that for each set of effect codes, one of the groups has -1s the whole way. Kind of similar to before when one group would have 0 the whole way, right? Here in effect coding, one group drops out, and that's the group coded as -1. The others, anything coded as +1 is compared to the grand mean. Everything else is coded 0 because we want these to add up to 0, -1 + 1 across. So we're going to set up these. And I'm going to go back to our recode. You can do it through the click-through, but this is pretty easy. We need to recode race into effect 1. So we're working on this first guy right here, or this first set. So race, and I can give myself notes. Recoding has contrast effects. To compare to grand mean. This one's going to be effect 1. Whoops, I went too far. See, I'm making a mistake. That's effect 2. This guy's effect 1. This guy's effect 2. This guy will be effect 3. Let's see what else I have to change. For effect 1, I'm comparing the grand mean, and Caucasian is going to be my base. It's not going to be in this regression. So Caucasian is always going to be -1. But then in here, they're going to be 0 unless they are the target. So for effect 1, Hispanic is the target and it's coded as 1. 0, 0, -1, right across. For effect 2, my target is Asian compared to grand mean. So it's going to be 0, 1, 0, -1. Good. And I can fix these too. Compare between Hispanic and grand mean. This one, comparing between Asian and grand mean. And the last one, comparing between. Effect 3 is between African American and grand mean. So just making sure all my labels are correct. I haven't lost any period or any apostrophe, and I have 1, 0, 0, -1, 0, 1, 0, -1, and 0, 0, 0, -1. Oh, that sounds wrong. It should be 0, 0 plus 1. So I need to change that. There we go. So pay attention to detail when you're working with syntax. It's just like coding in R. One little thing out of place and it doesn't work that right. Okay, so running that, got my effect codes in place, and now we're going to get a regression going. It's the same regression, but now with different effect codes applied to it. So instead of DUMS, I want the effects. F1, F2, F3. All right, that's ready to roll. And one thing I'll show you in here is that I can change, like we said before, if you go into preferences, so on mine it's under the SPSS statistics and then preferences. Sometimes it's under edit, but if I go to output here and say give me names and labels, let me set that, and now I'm going to rerun that same regression, and now see how it's got the names and the labels in there. So that work of compare between Hispanic and grand mean, it's right there on the table where I can see which one's which. I don't have to flip back and forth all the time. So between Hispanic and grand mean, that's my number, 5.220. So my grand mean is the intercept now. And my comparison between are those three. And what I don't have is the comparison between Caucasian and grand mean. But I have this that I can go ahead and write up the first regression equation here. 5168 is the grand mean, minus 348 is the African American, plus 632 is the Asian, and negative minus 522 is the Hispanic group. Were any of these significantly different than the grand mean? Yes, all of them were. African American, Asian, and Hispanic were all significantly different than the grand mean. So what we don't know yet is the difference between Caucasian and grand mean, if that's significantly different. So we will go do that. Now with effect coding, since it's just comparing to the grand mean, we only need 1 second regression to get Caucasian in there. We're just going to choose a different level to be the base, and then make sure that Caucasian has a target. So F4 will be Caucasian, and then Hispanic and Asian will be 5 and 6, with African American as the base. I'm going to go back to the syntax and grab the recoding. Recoding to get Caucasian. Comparison to grand mean. So now I want effect code. We went through 3, we want 4. 5. So now I'm just updating the script, and make sure you get everything. So for F4, I want 0, 0, -1, +1. 0, 0, -1, +1. And it's going to be comparison between Caucasian and grand mean. Whereas the next one is going to be Hispanic So I have 1, 0, -1, 0 for F5. 1 is my target, 0 not being used, African American -1 because it's the base, and Caucasian not being used. 1, 0, -1, 0 for F5 between Asian. Oh, look at that, I'm wrong. It's between Hispanic and grand mean. So make sure you have them right so that when they come to your output later, it doesn't confuse you on which one's which. And our last one is between Asian and grand mean. And my numbers are 0, 1, -1, 0. 0. Asian gets 1. My base gets -1. And Caucasian not being used gets 0. So I can check it over. And I can go ahead and run these to make the last set of effect codes here. Then we pick up our regression, paste it, and all we need to change is the effect codes going in here. 4, 5, and 6. Run. And now that comparison between Caucasian and grand mean, there's my number that I was needing. This one's still grand mean. Between Hispanic and grand mean is still the same, like when we look at before. Hispanic and grand mean still the same as before, and between Asian and grand mean is still the same as before. So all we were getting really was our number for Caucasian. Is the difference between Caucasian and grand mean significant? Yes, it is. So all groups were different than the average among the groups. Okay, some finishing touches. What other information is needed for the write-up? Use Daniel Soper online calculator that we looked at earlier. You're going to finish your descriptives table, so that's getting all that information that we collected at the beginning. like how many in each group, and the right by race and right by school type, mean, standard deviation, and how many in each of those groups to make your descriptives table there. And then just choosing your figures to help communicate to your reader. In SPSS, we got a bunch using the explore function. We got some box plots, we got some histograms, so you can choose which ones you want to use that help communicate the information that you're giving there. Take your time with it, see where you have questions, and I look forward to hearing from you. Well, that was a lot. We ran 2 different analyses, so the one about school type and the one about race, in terms of differences in writing proficiency, and we ran them both with treatment coding and we ran them with effect coding. And both of those are just choices you make as you are deciding your research question and what analysis is going to be useful for answering that research question. So as you noticed, I used prior footage for this lab, and you saw the little notes where things might have changed from then to now, but definitely let me know if you run into any challenges and we will work it through. Congratulations, you made it through all the labs in the GradStats 2024 season, and good job. I'll see you later.